Today's presenters are Lucidworks Director of Engineering and Solr Committer, Cassandra Targett, and Lucidworks SVP of Engineering, Trey Grainger. I'll now hand it off to Trey to get started. Thanks for joining us today.
Hi, everyone. Welcome to What's New in Solr 7. As Aaliyah mentioned, I am Trey Grainger, our SVP of Engineering at Lucidworks. I'm going to be co-presenting with Cassandra Targett, who is our Director of Engineering at Lucidworks, focused on our Apache Lucene Solr committer team. Those of you who may not know me, I am a co-author of Solr in Action, a Lucene Solr contributor, and I am a published researcher on numerous topics related to semantic search recommendations and data science. And Cassandra is a Lucene Solr committer and has been since 2013. And she's very passionate. One of her big projects in the Solr community is working on the Solr reference guide, and otherwise being a good source of leadership within the community. Lucidworks, for those who aren't familiar, is a San Francisco software company. We are the largest company focused on the Apache Lucene and Solr project, employing over 40% of the active committers on the Apache Solr, the active Solr committers. And we also contribute about 70% of the code to the Solr project. We also sponsor Lucene Solr Revolution, which is the largest open source user conference dedicated to Lucene and Solr, and we'll talk about that in just a few minutes. We've got hundreds of customers across the Fortune 1000, and in addition to Solr, we also have a product suite called Fusion, which we support as well. So the Lucidworks Fusion product suite goes beyond Solr and is composed of three key products: the Fusion Server product, the Fusion AI product, and the Fusion App Studio product. Fusion Server is the core NoSQL database that powers Fusion. It's a highly scalable search engine that's built on top of Solr. It also integrates Spark, lots of machine learning capabilities, and the ability to build world-class, highly scalable search platforms and apps. We have our Fusion AI product, which is the integration of lots of machine learning capabilities, everything from data classification to recommendation algorithms, signal processing, lots of natural language capabilities. And then we have our Fusion App Studio product, which allows you to build user interfaces so that you can easily get up and running, having a search interface in minutes or hours, having the ability to drag and drop search boxes and results and all those kinds of things on the screen, and really deliver with our entire Fusion product suite from data ingestion all the way to an end user experience very, very quickly. This is a sort of architecture of what Fusion looks like. I'm not going to spend time on that today, but for anyone who's interested, we'd be happy to talk with you about the Fusion product suite. We also have hundreds of customers across the Fortune 1000, and we really power search for the best and brightest of those companies with Fusion and Solr. And of course, I mentioned Lucene Solr Revolution a few minutes ago, getting some of the housekeeping out of the way up front. We have our annual conference. It's coming up very soon. It's September 12th through 15th in Las Vegas. We really hope to see you guys there. Our standard pricing just went up actually yesterday, but we talked with Aaliyah, and we're going to be extending it out through the end of this week. So for anybody who may have missed the deadline on the current pricing, you've got a couple more days after seeing the webinar to sign up. And it's going to be a great conference. We really hope to see you there. So for the talk today, what we're going to do is focus on everything that's happened since the 6.0 release, leading into Solr 7. So last year, Cassandra gave a talk on what's new in Solr 6, and so many things have happened over the last year. It's hard to even keep track of, and we'll touch on a decent chunk of them today. But there's so much material, we're going to have to leave some things out as well. But I'll sort of walk through at a high level what has been released in the last year, and then we'll specifically dive into some of the core topics that we found the most interesting and thought that you would find the most interesting. So last year when Cassandra spoke on Solr 6, a lot of the focus was on the streaming expressions framework inside of Solr. She also talked about the parallel SQL capabilities which had been introduced, cross-data center replication, the graph query parser, and some changes to the default similarity in Solr, switching from a pure kind of TF-IDF classic similarity to using BM25. Since Solr 6.0, though, a lot has happened. In Solr 6.1, in addition to the graph query parser, graph traversal streaming expressions were added. I'm going to talk about those in a few minutes, so I will leave that off for now, as well as a graph handler and the ability to export graph traversal queries in a GraphML response format so that they can be imported into other tools like Gephi and other graph visualization frameworks. Document classification was also added so that when documents are passed in, they can be classified on the fly. Distributed collection, backup, and restore capabilities. A GeoJSON response writer format for getting geospatial data back out of Solr in a standard format, as well as some additional streaming expressions. In Solr 6.2, more streaming expressions were added. Specifically, were some additions to the graph traversal capabilities to be able to score the nodes that were traversed, as well as the ability to train classification models and extract features out of text. Kerberos delegation support was added, and Kerberos secure impersonation support for those who are leveraging the security capabilities in Solr through Kerberos. And on the collections API, a delete node and replace node command was added. The core snapshots capabilities were added, an XML query parser was introduced, and the bin Solr script was enhanced to be able to have support for the Zookeeper to and from file operations. And I should mention on these next couple of slides, the things you see in green are things we're actually going to cover in more depth in just a little while. The things that are not in green are the things that we're just going to kind of gloss over right now. But if you have more questions about them at the end, we'll try to take some questions. In Solr 6.3, more streaming expressions were added, of course. Custom streaming expression support was also added. So if you want to write your own streaming expression, you can. The XLSX response writer was added. Collection snapshot capabilities were added, and the bin Solr script was enhanced further to allow you to be able to change the logging level. In Solr 6.4, again, more streaming expressions, and we'll kind of summarize all of those in a few minutes, were added. A new metrics capability was added, which provides APIs where you can directly access the core metrics inside of Solr, and we also are now exposing a lot of new metrics, which Cassandra will talk about in just a bit. A learning to rank capability was introduced in Solr 6.4. For those of you who aren't familiar, that's the ability to build machine learning models and use those as the basis for ranking your search results. I will dive into that in just a bit. A unified highlighter was added, and additional auth plugins were added to be able to delegate to the Hadoop auth framework and further enhancements to the bin Solr scripts to support the ZK make root command. In Solr 6.5, point field support was added. Point fields are something that was added in Lucene 6, but they're really kind of exposed out there, but they didn't show up in Solr until Solr 6.5. But they're much more efficient implementations of numerics and point capabilities. Multi-word synonyms were added. So one of the challenges in Solr over the years has been when you're leveraging synonyms, being able to support multi-word synonyms. So we spent a lot of time investing on fixing that problem once and for all. So that's now in Solr 7 and Solr 6.5 and beyond, really that's a problem that's been resolved. The V2 APIs were also introduced in Solr 6.5, which is a new, more modern JSON-based API format for you to be able to do the large majority of your operations in Solr. And in-place updates to numeric doc values were also added. So this is incremental field updates for at least numeric fields, having the ability to update fields without having to reindex the entire document or store the entire document. And that will be discussed in just a little bit as well. Solr 6.6, the ability to configure authentication via Solr in the bin Solr script was added. The upload command for config sets so that you don't necessarily have to interact directly with Zookeeper to be able to manipulate and upload config sets. And then payload query support was also added, which is a really cool feature we'll talk about shortly as well. The atomic update processor was added, and stream evaluators were added to the streaming expressions framework, which I'll mention shortly. So all of those things lead into Solr 7.0, and there's a few more really big improvements in 7.0 we'll discuss in just a little bit that Cassandra will go over. But starting out, I wanted to dive into a couple of the topics that happened between 6.1 and Solr and Solr 7 to be able to kind of give you an overview of what's in now. Streaming expressions, which I mentioned several times over the last slides, are a capability that initially landed in Solr 6.0 and which has continued to progress and improve with every release thus far, up until Solr 7.0, which is coming out now. For those of you who aren't familiar, streaming expressions are a simple yet powerful stream processing language for Solr with pluggable functions that can be combined to perform many different parallel computing tasks. So as an example, you see here on the screen, this is a hash join streaming expression that wraps two other streaming expressions, a search expression and a hash on another search expression. Streaming expressions leverage the doc values capabilities in Lucene and Solr to be able to rapidly process streams of values and do very interesting parallel algebra operations on them. And so going on to the next screen, just to talk about the kinds of things you can do with streaming expressions. They really enable you to build entire applications by combining functions together. So some examples are things like request and response streaming, batch stream processing, fast interactive MapReduce, things like doing distributed joins, intersections, unions, and complements. Again, these are distributed, so these don't have to all operate on a single Solr core. These can operate across an entire cluster, moving data around and doing distributed operations. Aggregations, the ability to do pub-sub messaging, and distributed graph traversal, which I'll show in just a minute. Other things like anomaly detection, recommendation systems, rank and retrieve services, and just general machine learning capabilities are now possible across the entire cluster based upon these streaming expression capabilities, as well as text classification and feature extraction, and the ability to do really interesting natural language processing. And as I mentioned earlier, streaming expressions are now pluggable, so you can actually build your own operations to operate on the data within Solr and tie those into and combine them with other streaming expressions. So the streaming expressions framework is basically composed of three types of expressions. You've got your stream sources, which are effectively the origination points for a streaming expression, which I'll talk about first. So streaming sources included in Solr are things like search, JDBC, etc. So imagine if you want to be able to run processing on a large stream of data, you have to have a starting point where that data comes from. So if you use a search streaming source, which is the first one we have on the slide here, then it will actually run a search against the Solr index, take the results, and stream those out to other expressions so that then you can operate on the results. Similarly, with the JDBC streaming expression, you can actually hit an external database, pull data into Solr, and have Solr process that stream of data, combining it and joining it and doing other interesting operations on it with whatever other information you've pulled into the streaming expression. So I'm not going to go over all of these, but I do want to just highlight that everything you see in green on the screen was added after Solr 6.0. All of these things are available in Solr 7. There's some really interesting capabilities, particularly if you look at things like the shortest path and some of the other graph traversal capabilities. Those have been added, as well as some of these expressions related to features and models, which allow you to actually build machine learning models inside of Fusion on the fly with streaming expression, save them into Solr, and then invoke them later, potentially as you're running a search, maybe wanting to classify the results coming out of the search. So all of these, again, are building blocks. You can put these together in very interesting ways, and I'll show you some examples in just a minute. But I mainly wanted to focus on, this slide in particular is all the places that you can start all the places you can pull data from, all the places that you can use as the source of a streaming expression. And once you've pulled data into a streaming expression, the next thing that you would want to do with it most likely is pass it through a series of stream decorators. So whereas the streaming expressions originate a stream, the streaming decorators take in a stream and output a stream on the other end. So a stream is basically represented by a bunch of tuples. So you could think of it as key value pairs coming, potentially representing every document or every entity that's being streamed. And so once you've got data flowing into the streaming expressions, at that point you might want to do a Cartesian product. Or you might want to take that data and pass it to a classifier that's been built. Or you can look at any of a number of other ones on here. If you've done a graph traversal, you might want to actually score the nodes in the graph that you've traversed to. So this slide gives you a good feel of all the different kinds of stream decorators that you can apply on streams in order to be able to ultimately get some interesting results out. One of the new capabilities that was added prior to Solr 7 is a new type of entity you can use in streaming expressions called stream evaluators. Stream evaluators, instead of operating on the tuples in the stream, actually operate on individual values. So imagine I've got a tuple as part of my stream, and I want to actually take one field out, for example, and I want to be able to manipulate it. So I can just pass that single parameter or value into a stream evaluator and actually transform it. And so what you'll see is that most of these stream evaluators are actually math-based evaluators, so things like divide, power, subtraction, addition, multiplication. And what this allows you to do is take the values from your documents or whatever you're streaming through and be able to manipulate those values before passing them on to additional stream decorators. So all of these are new prior to Solr 7 and are really powerful and interesting and something you might want to look at if you're playing around with streaming expressions a lot and haven't seen them yet. This slide gives you a few examples of what you can actually do with streaming expressions. So talking about them at a very abstract level is great, but if you want to actually put them into practice, we've got things here like, this first one's very simple. I just want to run a search and rapidly export all of the results. This next example is an example of a graph traversal where I'm actually trying to find the shortest path. I'm searching on email, emails from John and to Jane, and I'm trying to traverse across the email address and find the shortest path between the two of them. This one over here on the right is an example of a join. It's a hash join. I showed an example of that a minute ago, so I'll skip over it. I also mentioned being able to pull results from an external database. So this JDBC expression right here is an example of that. And I also mentioned machine learning models. So this bottom right example is training a logistic regression model by basically looking at collection 1 and creating a model based upon looking at the body field and extracting features. So once you've trained that model, then this model 1 model, you can actually invoke it later in another streaming expression. So this example is a classify streaming expression where I'm using this model that I just built over here on the right, running a search, and then classifying the results of that search before they come out of the streaming expression. And then one of the really fun ones here is this example of parallel batch processing. So effectively, we have a topic that is being represented by this checkpoint collection down here. You run a select that is pulling data from that topic whenever it appears. And based upon the results of that, you're actually updating a new collection, this destination collection, based upon that processing. This expression that's wrapping that is a daemon expression. And a daemon is basically a long-running process in Solr. So the daemon will continue to run in the background until all of the work is done. And then to make things run even faster, you can wrap this in a parallel expression. And so by combining and chaining these together in whatever way makes the most sense for your app, in this case, for example, we've created a parallel batch processing capability that is pulling documents out as they enter. And most of the examples on this page came from either the Apache Solr reference guide or Joel Bernstein has this, has a blog where he's talked about a lot of these as well. So we pulled a few from there. So I want to make sure we give give a good reference there with where all these ideas came from. So talking about all the streaming expressions that you just saw, one of the really interesting ones that's been added is the graph streaming expressions suite. So specifically, this gives Solr the ability to traverse and score relationships between documents within your distributed cluster. So a few things to note. These are implementing a powerful breadth-first traversal capability that work across both shards and collections. They support aggregations and are cycle-aware. They also give you the ability to both traverse and score nodes within the graph. So as an example, the gather nodes expression is one of the expressions you would use when trying to do graph traversal. So in this case, I have a movie collection, a movie lens collection, and I'm basically saying I want to traverse I basically want to look for the username of Trey and then gather all the movie IDs. If I've got separate movie documents, I want to gather all of the movies that I as Trey in the user collection have interacted with or that I've watched. The second example gives you shows you how to nest multiple graph expressions. So in the first one, I am trying to see for movie ID 123, I want to find all the users who have viewed it, and then after doing that, I want to find all of the other movies that those users have watched. So it's a two-level traversal here. And so some examples of when you would use graph traversal, if they're not obvious, are when you're trying to do things like anomaly detection or fraud detection. If you're trying to build a recommender to do collaborative filtering or something like that. If you want to do social network analysis, just general graph search, trying to basically do a join, but maybe a multi-level join. If you're trying to enforce access control or relationship discovery and scoring. So I've got some examples over here. I'm not going to dive into them for the sake of time, but just to give you one more example of an interesting use case for this, that's collaborative filtering. So this is users, going back to the movie example, based upon the fact that you've interacted with these movies, what other movies might you want to interact with based upon what other users have interacted with. So this inner search is looking for a specific user, and then from that we are looking at all the movie IDs that they've looked at and traversing to other movie IDs. And then from that, we're going to wrap that with another graph traversal looking at those movie IDs and trying to find other users. Let me make sure that's right. From the users who looked at those and looking at other movie IDs they looked at, excuse me. And so when you put all this together, it allows you to do some interesting recommendations based upon the data. Now, most of the times you've got a live system, you're going to want to do a lot of this computation offline, but this gives you an example of how you could do it all in one fell swoop with a streaming expression. And so in terms of the graph traversal capabilities, Grant Ingersoll, our CTO, and Tim Potter did a webinar previously that you might want to look at specifically on the graph traversal capabilities and also the SQL capabilities in Solr. So I'll refer you to that if you want to dive a little bit deeper into those concepts. Document classification, moving on to another topic, is something else that was added recently. It allows you to basically leverage Lucine's classification module to be able to classify documents on the fly. So I'm not going to dive into this, but basically there's two examples in the Solr reference guide. One is to do a k-nearest neighbors classifier, and the other example is to do a naive Bayes classifier. And so this is, you can reference these slides later or reference the video, but this basically shows you how to configure them in the Solr config.xml. And then, if you wanted to, pass your documents in and invoke the classification capability, you would do this. And if you wanted it to be invoked on every update, you would just configure that in your request handler such that a classification update chain is always invoked. But this allows you to leverage either the k-nearest neighbor or naive Bayes classifiers on incoming documents and then classify them based upon your existing inverted index. Payload queries and payload functions are another really interesting capability that was added by Eric Hatcher. leading into Solr 7. So payloads, for those of you who aren't aware, are arbitrary byte arrays that can be stored along with each term and position pair inside of your index. So if you look at this example up in the top right, if I'm indexing a field that has terms of 1, 2, and 3, I can pass a float payload in and of 1.0, 2.0, and 3.0, and those floats will actually be stored along with the terms in the document. So what that allows me to do at query time is some very interesting things. One of the examples that I can now do is do a payload score. So whenever I am running a query for some term, I can basically score that term based upon the maximum payload found for it. So that's an example of this payload score parser, which allows you to incorporate each term's numeric payload into the score. The payload check query parser is another example of how you can use payload. So in this case, instead of manipulating the score, it is actually filtering search results. So in this case, I can run a query for the keyword phrase searching stuff and say that I want to filter on only verbs and nouns. And then this payload check query parser will only match that keyword if in fact it was tagged with a payload of verb or noun. So this gives you some really interesting sort of second dimension capabilities when you're running a search against keywords. So you're not searching just on the keywords, you're also searching on some attributes of that specific instance of the keyword. And then finally, payload function queries were added, and these give you the ability to do if you're familiar with Solr function queries, these give you the ability to leverage payloads as part of the value that is outputted from the payload. So a lot of people use these for scoring as well and sort of pass in their own scoring algorithm as a combination of function queries. You can now leverage payloads as part of those as part of that scoring. Next topic is in-place field updates. So prior to this being implemented, there is a capability in Solr called atomic updates. And what these allow you to do is send in a single field update to a document and have it processed. The problem with that implementation is that it requires you to actually store all of the fields on your document. So in your schema, you have to mark all fields as stored equals true, because when that update comes in, it actually grabs all of the existing fields and reindexes the entire document. With in-place field updates, that's no longer the case. And so with in-place field updates, what you can do is, just to walk through this briefly, you can pass in a set or an increment operation, and it will actually modify the field in the document without reindexing the entire document. It only reindexes that one field. So a few caveats here. These are very kind of purpose-built and somewhat limited in terms of their scope. So specifically, it only works with doc value fields, and it only works when those doc value fields are not indexed, are not stored, and are not multi-valued. So a very common use case for this might be if you have an e-commerce or product catalog and you want to update the price on the fly. What you would do is you would have a field called price, and you would set it to be doc values, not indexed, not stored, and then you can update the price on the fly anytime you want without having to reindex the entire document. One of the other caveats I should mention here, in addition to the field you're updating, having to have these specific attributes, is that the version field in Solr, which keeps the version of your document, as well as any other fields that the value you're updating might be copied to, would have to also follow the same rules. They have to be not indexed, not stored, not multi-valued, and have doc values enabled. But if that's your use case, then I've got one example here of how this would work. Basically, if I have a document with a price field and a popularity field, I can pass in a document update that looks like this middle example here. And I can basically set the price to 99 and increment the popularity by 20. And you'll see that after I've done that, by only reindexing those fields, I now have a price of 99 and a popularity of 62 on my document. So if that's a use case you have, this might be an interesting capability for you to look at. Learning to rank is one other major capability that was added in leading up to Solr 7. And learning to rank is basically the ability to build and deploy a generalized relevancy scoring model, otherwise known as a ranking classifier, based upon a set of defined features and training data. This is commonly referred to as machine learned ranking as well in academic circles. So quick example of how learning to rank works. Obviously you need to have Solr up and running. So if you do a bin solr-e and you turn on the learning to rank capability, then you can actually play with this. So there's basically 6 steps here I'll walk through, and you can take this and play with it on your own if you want. The first thing you would do is run the search and see the current search results. And then based upon those results, you can supply relevancy judgments, which I'll show you on the next slide. And then you use a machine learning library to train a ranking classifier. You upload that model to Solr, and finally you can invoke the learning to rank query parser through a re-rank query, which I'll talk about in just a second. So just to walk you through this, let's say I have this example, which is right out of the tech products example that ships with Solr. I run a search for iPod, and you see 3 sets of search results here. The first one's for an iPod cable, the second one's for an iPod dock, and the last one is actually for an iPod. So these results don't look very good out of the box. So the way we would go about fixing this with learning to rank is by actually supplying a set of relevancy judgments. So I might have an analyst internally who is going in and telling me, for this particular query, and this is the set of document IDs, and this is how relevant each document is. Or I might have some way of deriving this from my search and click logs. Either way, once I've supplied these relevancy judgments, I then pass them to the training of my ranking classifier, which this example command at the bottom would do for you inside of that script, which ships with Solr. And then finally, once I've trained the model and pushed it to Solr, I can then re-invoke my query for iPod and invoke the learning to rank capability here. So to do this, you pass in an R2 parameter, which is a re-rank query, and I'm invoking the learning to rank query parser here, passing in my example model that I built. And I'm telling it to run the search normally, but then take the top 100 results of my initial search and re-rank those based upon this learning to rank model that I've just built. And as you can see here, the results now come back much better, with the Apple iPod actually being the top result and the other 2 being pushed lower. So this is a really interesting capability. I can't do it justice in a 2-minute overview here, but if you come to Lucy and Solr Revolution, you'll hear plenty of talks about this topic, and you might want to check it out for yourself. And with that, I'm going to actually turn it over to Cassandra now to take us the rest of the way through the capabilities leading up to Solr 7, and then some of the really interesting new things that have been added in Solr 7.0.
Okay, thanks, Trey. I'll start off talking about the V2 APIs just quickly. One second. I'm a little. There we go. Okay. Oops. A little too far there. Sorry. The V2 APIs actually. So this is basically we redesigned the APIs, which grew. The existing APIs in Solr, what we now sort of consider V1, grew a bit organically in an ad hoc way. No one ever sat down and actually tried to design a full API framework for all of the different things that we want Solr to have APIs for. So that's actually what was done here. So one of the biggest changes is that instead of assigning parameters in HTTP GET requests, at the end of your URL, now we actually send it with a JSON body and as a POST request. If we're going to be modifying the system. There are obviously some GET and delete requests that can be made. So it's a bit more, it conforms a bit more to standards. We also actually took a look at all the different endpoints and commands that are used and standardized and reorganized them. So the collections API, which exists today, now actually has additional endpoints depending on what part of your collection you're working on. It has a shards endpoint, a replicas endpoint, etc. It's also self-documenting using, if you add an _ introspect at the end of any URL, you'll get an output which is the specification for that endpoint. Includes links to documentation, full descriptions, and required or default parameters for each one of the parameters that you might want to use with each API call. Moving on to the unified highlighter, just kind of quickly, this highlighter, there's a presentation that was given on it last year at last year's Lucene Revolution, which I encourage you to take a look at. Essentially, the unified highlighter came out of asking, what if we could have a highlighter that combined the best of the existing implementations, the speed of postings highlighter and the accuracy of standard highlighter. So the postings highlighter was refactored a bit and improved. And then some of the code that's used in the standard highlighter was added to it. So the postings highlighter is actually deprecated in 7.0 and will likely be removed in Solr 8. So we're encouraged to use the unified highlighter instead. Trey mentioned the metrics API, which is a new API endpoint for all metrics. This actually, we use the CodaHail, Dropwizard CodaHail metrics library, and refactored metrics throughout Solr, and created metrics registries, which are groups of related metrics. And if you use the API endpoint, Solr admin metrics, it will show you all the metrics. So we added a lot of metrics and also reorganized a lot of them. So they have different names and different structure to them as well. We also added metrics reporters, which the JMX functionality in Solr is now considered a metrics reporter. We also have reporters available in the documentation that demonstrate how to set up for Graphite and Ganglia as well if you happen to be using those. And finally, another big thing that we did in Solr 6 was we redesigned and relaunched the Solr reference guide. And folks may not know this yet. Solr reference guide had been hosted on Confluence, and we had actually two big drawbacks to it actually, were that only committers could edit it. So there's really no way for non-committers to contribute to documentation, and sometimes users, non-committers, have some of the best ideas for how to change it. And we could never have online versions, online documentation that was appropriate for a specific version. It was always kind of looking forward and never had a version that was just for Solr 6.6, for example, or just for Solr 7.0. So we moved the reference guide to the Solr website, converted all of the pages into ASCII doc format, and developed tools to build the online version with Jekyll, and we use another tool to build the PDF. So we still release a PDF and we still have an online version. And essentially we're treating the docs as code. So that means we can take patches. We're committing it directly to the source code, to Solr source code. If you get the Solr source code, you have all the documentation right there. You have access to the build tools yourself. We can host versions for each Solr release, and we have Jenkins jobs that provide continuous integration, so we can see how all the builds are working themselves. I'll be giving a quick lightning talk on some of this at Revolution, and I'll focus there on patches for this. So, but definitely patches are welcome if you have suggestions for changes to documentation. So that takes us through the long list of stuff that we did in Solr 6. And there's several new things in Solr 7 that I'll talk about. And I want to leave a little time for questions, so I'll probably go through some of this rather quickly. We have some new replica types. There's obviously some deprecations, some ease of use improvements, and then auto scaling is a major new feature that we're adding. So we'll start with the replica types. Currently, the replicas, in your Solr cluster, all the replicas are eligible to become leaders if your leader happens to go down. But the cost of that is that they all must be in sync at all times. So all document updates are routed to each one of the replicas. Each one of the replicas needs to index those document updates and do a potentially expensive commit. If you have a large cluster with a lot of documents, that can be disruptive. And what we found what we found is that many users with large systems have been avoiding moving to Solr Cloud because the legacy master replica model performed better for them. So we thought some flexibility with this behavior would actually be beneficial. So what we've done is we've added 2 new types of replicas. The traditional type still exists. It's now called the NRT type, which stands for near real time. So updates are written to the transaction log and documents are indexed locally. Any replica could become a leader. Every replica performs a commit. This type supports soft commits if you do need the near real time functionality. 2 new types are the T-log and the pull replicas, where the T-log stands for transaction log. And in this case, document updates are written to the transaction log for that replica, but not to its index. It gets the index by using replication to copy segment files from the shard leader. This type, because it has a transaction log, can actually become a leader, and it does participate in elections. And when it is a leader, it behaves just like an NRT. It kind of switches types. A pull replica actually does not write to its transaction log and doesn't process document updates. It only replicates from the shard leader. So it's really fits the legacy model. It cannot become a leader, and it does not participate in leader elections. So what are some cases when you might want to use these types? And these are the recommended combinations of types. If you're fine with the existing pre-7.0 behavior, that's fine. You have all NRT replicas. And you want to use this if your index throughput is not too high and you maybe don't have a massive cluster. And particularly if you need near real-time support, this is the option you're going to need to use. You could choose instead to have all pull replicas, and you might choose this when you have a high number of replicas per shard. And again, obviously you don't need the near real-time support. You can mix the transaction log replicas with the pull replicas. Again, if you have a high number of replicas per shard and you want to prefer availability of search queries over index throughput. So if your index doesn't update very often, or if you don't mind having some stale data perhaps being served to your users, this actually would be a good option for you to use, because then you still have a few replicas that could become leaders if you lose a leader, and then you have the benefit of the pull replicas as well. To support this, we don't recommend mixing the NRT type, the traditional type, with the pull replicas because if one of the NRT types becomes a leader, it can cause the other replicas to become out of sync, which would cause a sort of cascading recovery through the pull replicas. So we don't recommend mixing this. I think we're starting out here. I think as we see how people use it, we could possibly add more functionality to remove that limitation. So it's pretty simple to use these. There's just when you create a collection, there's a few new parameters for the collections API. If you're adding a new replica, there's a new parameter there too to define the type. So if we take a look at a couple of API commands, and these are actually using the V2 APIs, so this is actually another example of that as well. You can see here actually I've defined in my create command, I'm defining a type of pull replicas and then a type of T-log replicas. And then I've defined the type during an add replica command as well. If you don't define, if you don't define any type of replica, the NRT type will be the default. So there's a few changes you should be aware of before upgrading. And I'll go through these actually very quickly. There's some field deprecations. The big thing to mention here is that all Trey numeric field types have been deprecated, and you're recommended to switch to using point fields instead. So obviously changing field types is going to require you to re-index, but that's something you might want to try to plan to do before Solr 8 comes out, which is where the Trey types will be removed. There's some other spatial field types that have been deprecated as well and replaced. There's some parameters that are no longer allowed, and one big thing to mention here is that the merge policy, merge factor, and merge docs, max merge docs parameter elements out of Solr config XML have been removed, and merge policy factor is introduced during 6x, and that's recommended to be used instead, and it actually supports these configuration options. For metrics, because of the refactoring that was done, the JMX in Solr config XML was removed. You're recommended to define reporters as instead, and metrics reporters are defined in Solr XML because they apply to the entire installation. MB names and attributes have changed, and they follow the hierarchical names that are used in the metrics API. And you can see this in action in Solr admin in the plugin screen for collection. Okay, and another big thing to mention on this screen is that JSON is now the default response format. So you don't need to add WT equals JSON any longer. That's actually the default. If you are relying on the XML output, you'll need to change requests so that you explicitly request XML. And as I mentioned, the postings highlighter has been deprecated as well and will be likely removed in Solr 8. These only sort of scratch the surface of the changes that were made. It's recommended before you upgrade that you try to do a good look through the changes.txt file. We'll also be writing some documentation for the rep guide with some deeper details about these. So some ease of use updates. There's now a default config set, so that if you don't define a config set when you create a collection or a core, the default sample config set will be used for you. This is a very minimal one that doesn't have a lot of things defined in it, but you no longer have to try to create your instance dir or upload your config set to Zookeeper or things like that. It also means that the admin UI, create a core, create collection screen now works as you might expect it to by just inputting the information that you want to define and hitting enter. There's also been some changes for schemaless mode where earlier releases sort of preferred sorting and faceting by creating new incoming text fields as string over searchability, which means you could facet on a field, but you couldn't search on it. Now what happens with the schemaless mode is that incoming new text fields are now indexed as a text general type with whatever name is in the document. And then those are copied to new string fields with the same name with the underscore str at the end for string. It says strings type, so it's allowed multi-values. And it will copy the first 256 characters out of the text field. These copy field rules for each one of the fields that it does this for are added to the schema. So because copy fields can slow down indexing slightly, if you don't need to sort or facet on a field, you can remove the copy field rule. You can also easily disable the auto create fields with a simple parameter. All right, so let's talk about auto scaling, which is a big new feature. And the goal of this is to make a cluster management easier by automating some collection and data load redistribution options. So if you have a cluster, if you're using Solr Cloud, you know today all the cluster management is manual. You provision a node, you tell Solr what cores to move to it, to put on it, where you decide when you should split shards, move replicas, etc. And we thought there were ways that we could make this a little bit easier. We thought we could lower the operational burden by, I think we could figure out a way to tell Solr what to do when a new node joins the cluster, and respond to a node leaving the cluster without manual intervention. And the way we've done this is with user configurable preferences and policies that set rules for what to do. So let's just take an example of a cluster. I have 3 nodes in this cluster, and I've got a few collections that have their cores distributed differently. If I take a look at this, I can think of a few things that are, I can see a few things going on here that I may want to take action on. Node 3 is getting a little low on disk. Nodes 1 and 3 are under a decent amount of load. Node 2 has the fewest number of cores. Collections 1 and 2 have most of their cores on node 1, and collection 3 has most of its cores on node 3. So if I was doing some analysis, if I was the operation in charge of the operations for this cluster, and I was doing some analysis, I might actually set up some rules for myself of what to do. I might say, don't put any more cores on node 3, it's getting low on disk. And then let's extend that and say don't ever put cores on a node that has less than 50 gigabytes of free disk. And I'd like to really prefer that cores end up on a node that has the most available disk, and prefer to put cores on a node with the lowest system load. So the way we've done that is with being able to set preferences for my cluster and then a policy for the cluster. So preferences define how to sort a list of nodes in a cluster. So if I'm doing an analysis to figure out where to put a new core or where to move a core, I can set up a set of preferences that's with these rules I just mentioned. Then I can set policies that actually set rules to follow, right? And these can be cluster-wide or collection-specific. So only do these things for certain, only follow the rules for a certain collection. And collection level rules don't override the cluster rules; they're added to them. So so that they basically augment them. And these are actually used by the Collections API to determine where to place new cores and replicas. One thing to note here is that the syntax for these rules, which I'll walk through, replaces the existing rule-based replica placement syntax. That existing syntax is not yet deprecated. We expect it to be at some point in 7X releases, which means the goal would be to remove it in 8. So if you are using those rules and you upgrade to 7, you may want to take a look at trying to translate those existing rules into a policy so that you'll be ready. Okay, so let's take a look at the preferences. With the preferences, we have a sort order, which is how to sort the values and what to sort by. Right now, we support cores, free disk, system load average, and heap usage. And then I have a precision, which is the minimum distance between the two values. Right, so I can actually say something like minimize the number of cores per node, but consider that if they're within 2 of each other, those are considered equal. So let's go back to our cluster here and just take a look quickly at how these nodes might be sorted. The sort goes from most loaded to least loaded. So if I have a rule that says minimize the number of cores and maximize the free disk, when Solr looks at the cluster, it says, okay, my first thing is to minimize the number of cores, so I'm going to sort by the number of cores. Now, node 1 and node 3 are considered equal because the 6 and 8 are within 2 of each other. So my second criteria is to maximize the free disk. So that actually, I have the most free disk on node 1. So that would actually say that node 3 is considered the most loaded by these preferences. So that would go first. Node 1 is next loaded because it has more free disk, and that would go second. In this case, the least load by these rules, the least loaded node is node 2. So the system would basically prefer to put new cores on node 2. It has a decent amount of free disk, and it has the least number of cores. Obviously, as I mentioned on the other screen, you could add in heap usage or the system load average to this and set that up. A policy, again, is a rule syntax which defines a set of conditions that a node, shard, or collection must satisfy, right? So I can set up a rule that says don't put more than 10 cores on any node. Only put a specific collection on a node that has more than 50 gigabytes of available disk. By default, these rules are strict, meaning that operations will fail if the rule cannot be satisfied. But you could set it to be more lenient, and then it becomes almost like a preference, right? You could say, I don't put more than 2 replicas on any shard, which I hope you have a lot of nodes. But if you can't do that, if you have no nodes in that case, then then it's okay to break the rule. Okay, so there's two ways that a node are applied, and we're actually going to try to do a webinar on this. I'm going to go. So I apologize if it's a little bit confusing, but we'll spend a little bit more time in another webinar for this. Rules can be applied to a node or to a replica shard collection combination. When it's applied to a node, we can only define the number of cores that are allowed, and the replica shard collection combination allows a little bit more flexibility to define the number of replicas allowed on a specific shard or on nodes that match certain additional attributes. So here's an example actually here. If I have an example here of setting, I don't want any more than six cores on any node, and that's straightforward, right? Then I can set up a rule that says I want no more than 2 replicas on each shard. Again, this is the same example as before. But I can also use arbitrary system properties, IP segments of the node, the role of the node, etc. And so here's actually the different attributes. I can use operators, as you saw, not, this, not, or less than or greater than. Some of these come actually from the metrics work that we did. The rules that we set, the preferences and the policy, are stored in autoscaling.json, which is stored in Zookeeper. And here's an example of what that looks like. So okay, that sets up a bunch of rules, which is great, but it doesn't actually do anything automatically, right? For that, we've developed something called triggers. And triggers watch for cluster changes and then generates events. So a node joins the cluster. That's an event, node added. And in response to that, what it does is it computes a plan of action. It runs through the rules. It sorts all of the nodes based on preferences, and then comes up with what it's supposed to do. And then it does that, right? So auto-add replicas is actually considered a trigger. So let me just show, and I'll talk about auto-add replicas in a second. Here's kind of an example of what this would look like in autoscaling.json. I said, here's my event, is a node lost. I want to wait for 30 seconds, and then I'm going to compute my plan, my auto-add replica plan, and then I'm going to execute the plan. So for auto-add replicas, as you may know, it has until 7.1 is automatically adding replicas if a node is down or lost. It is only available when storing an index in HDFS. So in Solr 7.1, I'm getting a little ahead of 7.0, but in 7.1 we've extended this to all the replicas in a cluster no matter where they live. So if you add auto-add replicas equals true to any collection, Solr monitors for down states. The trigger produces the node lost event. The compute plan determines where to put new replicas according to the cluster preferences and policies. Attached to triggers, you can have listeners, which perform different tasks. So I can have a listener listening for each stage of the trigger and then doing something, logging, sending a URL to an external system, etc. I'm going a little bit faster because we're almost out of time here. There's an API for this that allows it to do some things. So I can set my policy, set my preferences. Again, this is following the V2 API structure here. There's a diagnostics endpoint which will show me the list of sorted nodes and how they're sorted. This output is not related to the earlier ones. I actually pulled a different example. But this actually shows me the way my nodes are sorted and shows me if there are any violations to my policy or preferences. And then these are used, actually starting in 7.0, these are going to be used by the collection API to determine where to put new shards and replicas if you do not specify them. So it'll be used by add replica to decide where to put your new replica. Okay, so I wanted to hand it back to Trey just to finish up.
Cool. Thanks, Cassandra. Good stuff. So yeah, everybody, we mentioned Lucene Solar Revolution earlier. Obviously, this was a kind of brief overview of the many things that have come since Solar 6.0. We did want to highlight a few specific talks that are going to be at Lucene Solar Revolution, around analytics and graph traversal, learning to rank, payloads in Solr, new replica types, monitoring and metrics. And honestly, there's 60 additional presentations that are going to be happening. So if you want to learn more about all of these topics, definitely sign up. We'd love to see you there. With that, Leah, I'll hand it back over to you. I don't know if we have time for a couple of questions, but we'll conclude with that.
Thank you. Thanks, Trey, and thanks, Cassandra. We are about a minute over. We'll just ask one of the questions we got. Any other questions that we don't get to, we'll be sure to reach out and get someone to answer those for you. So I'm just going to pull one out. This one, and Trey or Cassandra, whoever's comfortable answering this, go ahead. The person asks, if I'm using Lucidworks Fusion's signals capability, how does that differ from the new learning to rank functionality in Solr?
Cool, I can take that one. Yeah, so if you're not familiar with Lucidworks Fusion, we have had for a long time a capability in there called signals, which basically, as users are running searches, the searches, the clicks, and any other information relevant to actions that user has taken on the documents is fed back into Fusion. And we have processing that happens on those signals, and we can invoke machine learning algorithms, et cetera. But by and large, we take the feedback from the users, figure out what was relevant to them, what they most likely clicked on, and then use that to boost the results. And the impacts are staggering across our customers in terms of the relevancy improvements that they see, and click-through rates and purchases and those kinds of things. Learning to rank is similar in the sense that it uses feedback on relevancy, so a query and document pair, and how relevant each of those sets of documents are. The fundamental difference is that whereas with signals you are learning the actual documents that were the most relevant and boosting based upon that, with learning to rank you actually are instead building a model. And so one of the downsides of learning to rank is that you still have to do feature engineering, and you have to sort of figure out what are the likely things that are going to matter for the relevancy calculation. But then you can use relevancy judgments to train a generalized model that can apply to future documents that maybe the engine hasn't seen yet. So I would say that's the fundamental difference. They're actually both very valuable capabilities. They serve slightly different needs, but you could also pair them together if you wanted to have both a generalized model for new documents you haven't seen before, and also a model which understands the specific content and user interactions that you have.
Thank you. All right, so we are officially over time. Everyone who registered for this webinar will receive a link to the recording shortly, so look out for that. Again, if we didn't have time to answer your question, we will reach out to you. Thanks again for joining us today, and we hope you enjoyed the webinar. Thanks, Trey and Cassandra.
Thanks, guys. Thanks, Leah.
Thanks.